In this video, we will learn about quadratic equations. And specifically, we will learn what a quadratic equation is, how to solve them, and then we'll talk about what's called the discriminant. And at the end, we'll work with a couple example word problems. So to begin, let's define what a quadratic equation is. So in standard form, we can say that a quadratic equation would be something in this format, where we have ax squared plus bx plus c equals 0, where a, b, and c are some sort of real number, and a is not equal to 0. So basically anything with an x squared term would be a quadratic equation. So like x squared minus 4x equals 3, that's a quadratic equation. X squared plus 4 equals 0, that is also a quadratic equation. Anything like that would be quadratic. If it's anything bigger, so like x cubed, that would not be quadratic. That would be a cubic equation. If it's just something like this, okay, that is not quadratic either because there's no squared term. So with quadratic equations, to solve these, we need to understand what is called the zero product principle. And this says that if we have two numbers, we'll call them a and b, then if a times b is 0, we know that either a would equal 0 or b equals 0. Right? So for example, if you had two numbers multiplied together equals 0, let's say we had a and b, the only way to get an answer of 0 is if one of these two numbers are equal to 0. And that's what the zero product principle says, that one of those two things must equal 0. So this is going to help us out because a and b could be anything. So if we had something like x minus 4 times 2x plus 3 equals 0, instead of a and b, we have these two binomial expressions. Well, if we get it to look like this, we know right away that either x minus 4 would equal 0 or 2x plus 3 equals 0. One of those two things must be true because the product is equal to 0, and the only way for that to happen is if one of those parts is equal to 0. So what this is good for is we can use this to solve a quadratic equation, where if we can get it factored on the left side and set equal to 0 on the right side, we can solve. So for example, here we have 2x squared plus 7x minus 4 equals 0. Now at this point, we're assuming you know how to factor, so we're going to kind of go through that part quickly. But the left side does factor, and you would get 2x minus 1 times x plus 4. So if that is true, okay, and it's equal to 0 when you multiply those two binomials, what we know is that either 2x minus 1 would equal 0, or x plus 4 equals 0. So we can then solve each equation. First one, we add 1 to both sides to get 2x equals 1, then divide both sides by 2, so x would equal 1 over 2. So x equals 1/2, or over here, if we solve for x, we get x equals negative 4. So we have two possible answers. X could equal 1/2, or x could equal negative 4. So to recap this process, we need to get our equation equal to 0, and on the left side, we need to factor. So if it's not equal to 0, make it equal to 0, and then if it's not factored on the left side, then you factor. So that's the thought process behind any problem like this. Another process we can use to solve quadratic equations is solving by taking roots. This process says that if x squared equals c, then what we can do is we can take the square root of both sides so that x equals a positive or negative square root of c. What that looks like in an actual example is, say we had 2x squared minus 3 equals 13. Basically what we're doing is we're solving by working in reverse order of operations in this case. So we just basically isolate the x in this equation, because in this problem there's only one x written here, as opposed to the other type that we just showed. It had an x squared and an x term. So if you see it just in one term like this with an x squared, we can work in reverse order of operations. So we take care of subtraction first. We do that by adding. So we add 3 to both sides to get 2x squared equals 16. And then we take care of division next. So we divide both sides by 2. So we have x squared equals 8. So what was being stated up here is that if it's in that format of x squared equals c, which is what we have now, x squared equals 8, what we do is we can take the square root of both sides, because that will effectively get rid of the square on the left side. So now we have x on the left, and then a positive or negative square root of 8 on the right. So we could type that into our calculator to get a decimal answer. Or if you keep it with a radical, you want to make sure that you simplify. So we're assuming you know how to do that pretty well. But the square root of 8 you could write as the square root of 4 times the square root of 2. And the square root of 4 is 2. So 2 times the square root of 2. And that is our simplified number. So what we have is plus or minus 2 times the square root of 2. So we have two answers. We have a positive 2 squared root of 2 or a negative 2 squared root of 2. So you can write it like this, or you can write it out as two separate answers. You have a 2 squared root of 2 or negative 2 squared root of 2. Okay, there we go. So we can write it like this, or as one answer plus or minus 2 squared root of 2. So in the notes, we see it all typed up right here on the left side. Over here on the right, we have another example where it is similar. And again, we can solve by working in reverse order of operations. So we see subtraction, we see parentheses, and we see an exponent. So we can take care of subtraction first by adding 2 to both sides. So that would give us, on the left, x plus 1 squared. On the right, we would get 16. So now we can take care of the exponent, right? So we do the exponent before parentheses. And to do that, we can get rid of that by taking the square root of both sides. On the left, it will effectively get rid of the squared. So now we're left with x plus 1 on the left. And on the right, we have a positive or negative square root of 16, which would be 4. So what we have is x plus 1 equals 4, or x plus 1 equals negative 4. So you solve each of those, x would equal 3, or x would equal negative 5. All right, so this is another way of solving. So we've worked with the factoring process using the Zeroproduct principle. This is solving by taking roots. Our next method is solving by completing the square. And the example we're going to look at is x squared minus 2x minus 4 equals 0. So notice right away that this does not factor. So we cannot use that Zeroproduct principle to solve. And what that means is we're stuck with using another method. So we can use either completing the square, which is what we're going to do here, or we can use the quadratic formula, which is our next method. So completing the square, what we do is we're trying to force this left side to become a perfect square trinomial, so that we have something in parentheses squared equaling a number over here on the right side. So to make this work, what we do is we need to bring this constant term of negative 4 to the right side. We do that by adding. So now we have x squared minus 2x on the left, and then positive 4 on the right. So from here, on this left side, we're going to add something so that it becomes a perfect squared trinomial. We're going to add the same thing to the left and to the right side to keep the equation balanced. So the number we're adding can be found by looking at this middle number right here, the negative 2. What we do is we take half and then square. So half of negative 2 is negative 1, and then you square negative 1 to get positive 1. So you add 1 here, add 1 on the right side, and what that does is on the left, this would now factor to be x minus 1 times x minus 1, or x minus 1 squared. And now at this point right here, we can take the square root of both sides to solve. So now we have x minus 1 equals a positive or negative square root of 5. And then solve for x by bringing this negative 1 to the right side. We do that by adding 1 to both sides. So what we have now is x equals 1 plus or minus the square root of 5. And that is our solution. We could leave it like this. If you needed an actual decimal answer, you could type in the square root of 5 into your calculator to get some decimal. Then you do 1 plus that decimal to get one answer, and then 1 minus that decimal to get the other answer. Here's a second example of 3x squared plus 12x minus 27 equals 0. This one's different than the first one because what we have is a coefficient right here in front of the x squared term. So two things we need to do. One is get rid of that 3 in the front. The other is we need to bring this 27 to the right side like we did originally for the first equation. So it doesn't matter the order in which we do that. In the notes, we brought the 27 to the right side first by adding. So now we have 3x squared plus 12x on the left, and then positive 27 on the right. So now we can get rid of the 3 in front of the x squared term, and we do that by dividing every term by 3. 3x squared divided by 3 is x squared, 12x divided by 3 is 4x, 27 divided by 3 is 9. So now, notice it's in the exact same format that we had right here with this first equation. And now we can add something to both sides to make the left side a perfect square. That number, again, is found by taking this middle number, the 4. You take half and then square it. Half of 4 is 2. 2 squared is 4. So we're adding 4 to both sides of the equation. So on the left, now we can factor to get x plus 2 times x plus 2, which is x plus 2 squared. On the right side, we have 13. So now we can solve by taking the square root of both sides. On the left, we have x plus 2. On the right, we have a positive or negative square root of 13. And then to finish off, we can subtract 2 from both sides to bring the 2 over to the right side. So when you subtract 2, now we have x equals negative 2 plus or minus the square root of 13. So I should note that so far the radicals have not been able to be simplified, but if it needs to, make sure you simplify the radicals. We have a third example we're going to show you, and this one is going to involve fractions. So it's the same exact process, but it's a little messier because of the fractions. And here we have 3x squared minus 2x plus 4 equals 0. So one thing we need to do is bring the 4 to the right side. So always bring the constant to the right. So we do that by subtracting 4. So now we have 3x squared minus 2x equals negative 4. And then we need to get rid of this coefficient with the x squared term. So we divide everything by 3. So 3x squared divided by 3 is x squared. Negative 2 divided by 3 is negative 2/3. And then negative 4 divided by 3 is negative 4/3. All right, so the steps are still the same, and we still need to add something to both sides to make the left into a perfect square trinomial. We do that again by taking this middle number, negative 2/3. We take half of that, so we multiply by 1/2. That gives you negative 2/6, or negative 1/3. So you take half, and then you have to square this number. So you square to get positive 1 over 9. So the number we're adding to both sides is going to be 1 over 9. Now the tricky part on the left side is knowing how to factor with the fractions. We know it's going to be x, something here, and then squared. And the something that goes here is going to be the number we squared to get to the 1/9. And that was the negative 1/3, right? Negative 1/3 squared gave you the 1/9, and that's what goes right there. So on the left, we have x minus 1/3 squared. On the right, we can add negative 4/3 plus 1/9. So 4/3 is going to be 12/9. So negative 12/9 plus 1/9 gives you negative 11/9. So we see everything typed up right here. And now we can get rid of the square by taking the square root of both sides. So now we have x minus 1/3 on the left, and then plus or minus the square root of negative 11 over 9 on the right. So we can solve for x by bringing the 1/3 to the right side. We do that by adding 1/3 to both sides. So x equals 1/3 plus or minus the square root of negative 11 over 9. Now one last thing to take care of is this radical. So we need to rationalize, where we get rid of the denominator inside of the radical. And we also need to take care of the negative inside the radical. So looking just at that radical part, Okay, we can pull out the negative. That's an imaginary component. So we can pull that out by doing putting I out there. So we have I times the square root of 11 over 9. All right, now that radical we can separate. We get the square root of 11 over the square root of 9. The square root of 9 is 3. So we have I times square root of 11 over 3. And normally we write the I on the right side of the number. So we see that typed up right here, where you have the 1/3 plus or minus, and then the square root of 11 over 3 times I. So this would be your answer to that equation. All right, so now another method we could use is called the quadratic formula. And the derivation of this, we're not going to go through how we got the quadratic formula. It suffices to say that we can just use completing the square on the general or standard form of the quadratic equation. So if you take ax squared plus bx plus c equals 0, and you go through the completing the square process, you're going to get this formula. So make sure you have the formula memorized. All right, so we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So a, b, and c, the numbers we're plugging into the formula, are found when you have it in this format. So it needs to be in standard form, where it needs to be equal to 0, and the a is the number with the x squared term, b is the number with the x term, and then c is your constant. So if you're given an equation like this, 9x squared minus 11 equals 6x. In order to use the quadratic formula, we need to set equal to 0. So we can do that by bringing the 6x to the left side. We do that by subtracting 6x from both sides. So on the right, we would have 0. On the left, we would have 9x squared minus 6x minus 11 equals 0. So now we have a would equal 9. So a is 9. Okay, b would be the negative 6. And c would be negative 11. So we take the formula and just plug in the numbers. All right, so we have x equals negative 6, which gives you a positive 6, and then plus or minus the square root of b squared, so negative 6 squared, that would be 36, minus 4 times a is 9, times c was negative 11. All that is over 2 times a, which is 2 times 9. All right, so we just now need to solve this. So we see that typed up right here. Negative 6 squared we said was 36, and then negative 4 times 9 is negative 36, times negative 11 would be positive 396. And then 2 times 9 is 18 on the bottom. So now from here, 36 plus 396 would give you 432. And then the 432, we can simplify that radical. All right, it's not a perfect square. So when we simplify, all right, 432, we can break it apart. It's even, so we can divide, well, we divide by 4 actually. That'd be 108, 4 times 108. 108 would be 12 times 9. 12 is 4 times 3. So what we have is a group of 4s. And actually, okay, 9 is 3 times 3. So we have a group of 4s, we have a group of 3s. So we pull out a 4 and we pull out a 3. You're left with this 3 on the inside. That would give you 12 times the square root of 3. So then from here, we can simplify one last time by dividing every term by 6. So if we divide every part by 6, that gives us 1, 2, and 3. So our final answer would be 1 plus or minus 2 times the square root of 3, and all that is over 3. All right, so we've worked with different methods of solving. Okay, we did quadratic formula, completing the square, and some other ones as well. Now moving forward, we want to discuss what is called the discriminant of a quadratic equation. So the discriminant is a portion or part of the quadratic formula. And specifically, it's the part inside of the radical. So in the formula, right, we had x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. The b squared minus 4ac part right here, that is called the discriminant. And it's called the discriminant because it discriminates or tells us something about the types of answers we're going to get. All right, so it's going to give us information as far as like if it's going to be real or imaginary. It'll tell us if it's going to be rational or irrational answers. It'll tell us the number of answers. So that part tells us a lot of information about the types of answers we're going to get. So if that part is positive, so if it is greater than 0, what that means is that we have real answers, right? Because we have a square root of a positive number. And it's going to be positive or negative square root. So we have a positive answer and then a negative answer from that. All right, so that gives us two different answers, two different real answers. If it's equal to 0, we have plus or minus 0, plus or minus the square root of 0, which is 0. So adding 0 and subtracting 0 is the same thing. So what that means is we're going to have just one answer if it's equal to 0. If it's less than 0, so the part in the radical is less than 0, that means we're going to have an imaginary answer. All right, so if it's less than 0, we have two different imaginary or complex answers. Complex meaning imaginary. And the two answers would be conjugates of each other. So it's going to be something plus a number and then something minus a number. So now, using that idea of discriminant, we're going to look at 3 examples where we need to determine the type of solutions that we have. So our first example with discriminant is x squared minus 9x plus 20 equals 0. So if you're trying to determine what type of answers we're going to get, we can plug it into that discriminant part of the quadratic formula, the b squared minus 4ac, where a is 1, b is negative 9, and c is 20. So when you do that, we get negative 9 squared plus 4 times a is 1, times 20, which was our c value. So negative 9 squared would give you 81, and then minus 4 times 1 times 20 is 80. So we have 81 minus 80 equals 1. And so what that means is that's the part inside of the radical. So we have plus or minus the square root of 1. So we know from this that we're going to have 2 different real answers because of the plus and minus. That gives us 2 answers. And it's real because this number here inside is not negative. Now what if you had 3x squared minus 6x plus 3 equals 0? So again, we can use our discriminant of b squared minus 4ac. A would be 3, b is negative 6, and c is also 3. So if you plug that into the formula b squared minus 4ac, we would get negative 6 squared minus 4 times 3 times 3. 4 times a, which is 3, times c, which is also 3. What that gives us is 36 minus 4 times 3 times 3 is also 36, and that equals 0. So what we have is a plus or minus the square root of 0. So because it's a plus 0 and minus 0, that gives us the same answer. So what we have is just one answer, and it's going to be real because it is not a negative inside the radical. So this would be one real solution. Here's the third example. We have 10x squared minus x plus 9 equals 0. So again, we can use the b squared minus 4ac, where a is 10, b is negative 1, and c is 9. If you plug those numbers in, we're going to get negative 1 squared instead of b squared, minus 4 times a was 10, times c, which was 9. So we have 1, and then minus 4 times 10 times 9 is negative 360. And that gives us 1 minus 360, or negative 359. So what that means is that is the part inside of the radical for the quadratic formula. So because we have a square root of a negative number, we have an imaginary answer, or we call it complex as well. It's another name for it. So we have two different complex answers because we have a plus and minus, so we have two different ones, and it's complex or imaginary because the negative is here inside of the radical. Now to finish off the lesson, we're going to work through two different application problems. So here, the first one is using Pythagorean theorem. So make sure you remember the Pythagorean theorem. You learned this back in geometry. And this theorem says that a squared plus b squared equals c squared. And it's used for a right triangle. Okay, if you have a right triangle, in that formula, a and b would be the two legs. And then the hypotenuse, which is across from the right angle, that is your c value. So if you have that memorized, here's an example using that Pythagorean theorem. So for this problem, we are told that Carol's laptop screen has an aspect ratio of 16:9, which means the width to length ratio is 16:9. The diagonal of her laptop screen is 13.3 inches. What are the width and the length of her laptop screen? All right, so a laptop is going to be a rectangle. So it's going to be a rectangular shape. So it's going to look like this. All right, the diagonal, so across like this, is going to be 13.3 inches. That was given to you. And the ratio is 16:9, length to width. So the ratio 16:9, what we can do is we can make the length 16 times x and the width 9 times x. Because if you write that as a ratio, 16x over 9x, that gives you the ratio of 16:9. So we don't know exactly what x is, right? We don't know the exact dimensions, but we do know that it's in that ratio. So that would be your setup for the picture. And we see that typed up here on the left. Now from this point, notice we have a right triangle. So here we have two of them, but let's take a look at just the one. Okay, so we have a right triangle, and that means we can use Pythagorean theorem. A squared plus b squared equals c squared. So a would be the 9x, b would be the 16x, and c would be your 13.3. So plug those into the formula. We get 9x squared plus 16x squared equals 13.3 squared. Well, 9x squared would be 81x squared. 16 and x squared would be 256x squared. And 13.3 squared is 176.89. So from here we can combine like terms. So 81x squared plus 256x squared, that would give you 337x squared. And then we can solve this. We have a quadratic equation. So we can isolate the x value by dividing both sides by 337. So when you do that, we have x squared on the left, 176.89 divided by 337 on the right would give you 0.5249. And then to finish off, to solve for x, we can take the square root of both sides. So now we have x on the left, and the square root of 0.5249 would be 0.7245. So we've solved for x, and we've not completely finished because x is not the width or the length, but we can use it to find both. All right, the width was 9 times x. So if we do the 9 times 0.7245, that would give us the width, and the length would be 16 times 0.7245. So here, this should actually be length. Length equals the 16 times 0.7245, which gives you 11.592 inches. And the length, when you do the 9 times x, we get 6.52 inches. So the length and the width were switched on accident, but those would be the dimensions, 11.592 and 6.52 inches. Let's take a look at one more example. Here we are told that Kyle has a lawn mowing business. One lawn he mows is a perfect rectangle with length being 4 feet longer than twice the width. If the area of the lawn is 1,350 square feet, what are the dimensions of the lawn? So when you begin this, it's helpful if you draw a picture. You don't have to, but it's helpful many times. And it says the length is 4 feet longer than twice the width. So the width would be W. The length in relation to that is 2 times that, 2 times W, plus 4, because it's 4 feet longer than twice the width. So we know that, and we know the area is 1,350 square feet. So that would be our picture that we want to use. And we see that over here on the left. Now area is given to us. So that means we need the area formula for rectangle, which is base times height or length times width, same thing. And so we take what we know, so the area is 1,350, you plug that in, and then the length is 2W plus 4, and the width is W. So that would be your equation, and we see it typed up down here. So the W outside the parentheses we can distribute to get 2W squared plus 4W. That's equal to 1,350. So now from here we can solve. We have two terms with W. So we're going to want to use completing the square, quadratic formula, or maybe factoring would work. So let's bring the 1350 to the left side. So we bring it over by subtracting. That would give you 2W squared plus 4W minus 1350 equals 0. All right, different ways we can approach this. You can use whatever method you prefer. You could actually divide everything by 2 to make the number smaller, or you can just take what you have and use it that way. So here in the notes, we'll just take these numbers and plug it into the quadratic formula. So make sure you have that memorized, because when you plug it in, we're just going to do it quickly here. So your formula is right here. So A would be 2, B is 4, C is negative 1,350. So when you plug the numbers in, we have negative 4, right, because negative B is negative 4, plus or minus the square root of B squared. So B squared would be 4 squared, or 16, minus 4 times A times C, so 4 times 2 times negative 1350, all over 2 times A, which was 2 times 2. All right, so inside the radical, we have 16, and then negative 4 times 2 would be negative 8. Negative 8 times 1350, we get some number, and then when you take the square root of that number, you can use your calculator, you're going to get 104. All right, so you just use a calculator to get those numbers. And then from here, you can solve, where you do negative 4 plus 104 over 4. That would give you 100 over 4, or 25. That's one answer. Or you could do negative 4 minus 104, which is negative 108, divide by 4, and that would be negative 27. So we see that typed up right here. And notice negative 27 does not make sense, because width is a length of something. It cannot be negative, right? So it's got to be positive. So we have positive 25, and then that would be the width part. Now the length is 2 times 25 plus 4, so that would be 50 plus 4, or 54. So the dimensions of the lawn are 25 feet by 54 feet. So in this lesson, we've learned all about quadratic equations. We've learned how to solve them. We learned about the discriminant, and then we learned how to apply it with different word problems. And that concludes our lesson for today. We will see you next time.